Hi, welcome to the wonderful world of solids where things can get a little bit tricky. Did you know that solids can be classified into two groups based on their atomic dance moves? That's right. We have the smooth and funky moves of the amorphous solids and the perfectly choreographed routines of the crystalline solids. The way the atoms or molecules move and groove in the solid state determines which group they belong to. So let's get ready to groove and learn about these fascinating solids. So, now you know that solids are usually classified as either crystalline or amorphous. In this lesson, our main focus will be on the fascinating world of crystalline solids. A crystalline material is one in which the atoms, molecules, or even the ions are arranged in a highly regular repeating pattern or lattice. Lattice simply refers to a grid-like repeated structure. This fence, for example, is a two-dimensional lattice. It is best to consider a simple crystal as a structure made up of a large number of building blocks known as unit cells. The way the atoms or molecules are arranged in the unit cell is the same way they are arranged throughout the solid. As we stack these unit cells side by side and on top of each other, we build the entire lattice. The unique three-dimensional arrangement of atoms or molecules in a unique cell, and by extension a crystalline solid, is called its crystal structure. These crystal structures are revealed by X-ray diffraction. The following are the basic types of crystal structures. We have the simple cubic lattice. We have the face-centered cubic, that's the FCC. And we have the body-centered cubic, the BCC. In a simple cubic lattice, the atoms are arranged at the corners of an imaginary cube, and an example is polonium. In the face-centered structures, the unit cell has identical particles at the corners and another particle at the center of each face. Examples are copper, silver, and lead. A body-centered cubic lattice has the atoms arranged at the corners of the cube-shaped lattice and an atom at the center of the cube, and examples are iron, chromium, and tungsten. Now, note that the lines that make these shapes are imaginary. There are actually no lines connecting these atoms. These lines were introduced to enable us understand the placement of the atoms and the molecules within the crystalline material. In the next lesson, we will discuss the other type of solid structure, which is the amorphous structure, and then we compare their physical properties. See you soon.